About voltage drop, one of the important part of the Canadian Electrical Code Book and the Red Seal exam. Be with me till on the end of the video, so you can be sure that you can pass the all questions about the voltage drop in this exam, Red Seal 309A. First question, what is the maximum allowable voltage drop for 600 volt 3-phase 4-wire branch circuit installed in an industrial environment? So how can we calculate the voltage drop? Most of the time voltage drop is 3% when it's not marked. So 600 volts by 3%. You can write 3% like this. It's 18. 600 by 3, 18 volts. 18 volts is the answer for this question. 18 volt is the answer. And next question, what is the minimum copper conductor size? This question asks us about the conductor size, minimum size required for 6 volt emergency lighting system carrying 4 amps over a distance of 15 meters. Okay, so for this kind of questions, always we have fixed and constant formula that always remember table D3. Appendix D, table 3. So we go and check this in the Canadian Electrical Code Book. Let me to Appendix D. Appendix D, and let's go to the D3. Okay, this one, all this table or about all this one and the next one. You can find the formula here, the most important formula, Vd equal to K by F by I by L. L is length, I is ampacity, F you can find F from the continue of the table here. Most of the time F is 2, and K you can find K from this table. Table D3, and VD. VD is the voltage drop. So let me to write this formula here. VD equal to F by K by F by I by L. Divide 1000. Okay, so in this question, what is the minimum copper conductor size? So for this question we need to let me to show you the table. This table, you can see the first column is the size of AWG and KC mill. These are the size of the cables, and the next columns are the K. All of these numbers, these digits are K. So with this table you can, if you have the K, you can find the right size of the cable. So first we need to find out, in this question we need to find out the K. So from this equation we can find out that K equal to V D by 1000. If you bring 1000 to that side of the equal, and let me to put it in the bracket and divide by divide F, I and L. So we need to calculate the K, and so first of all we need the VD equal to VD we have the voltage, we have we don't have the percentage of the voltage drop, but imagine that it is 3% because it's a minimum size of the cable. So V by volt, let me 6 by 3 equal to 8 volt. This one is voltage drop, and we need, in this formula we already calculated this VD. We need F is 2, always, most of the time F is 2, and we need I is 4, and we need L is 15. So I is 4 and L is 15. So let me copy this question. Let me to copy this question and write it here. So equal VD is 18 by 1000, and divide by 2 by 4 by 15. So let me to use calculator. 18 by 1000, it means 180 divide 2 divide 4 divide 15, it's 1.5. So K is 1.5, and then we can check the table, because this question is about the DC direct current, this emergency lighting system. So this one is DC, so we can check this column, and for 1.5 we can use 6 AWG, number 6 AWG. So the answer is this one, and that's it. So from table we got that number 6 AWG, and that's it. We have the cable size. Next one, what is the maximum permissible circuit length? Okay, circuit length, so it needs L for 12 volt emergency lighting system. So we have the voltage supplying 8 okay, so supplying 8 6-watt lamps. So we have total power of the consumer. So let me to write it. P total equal to 8 by 6 watt equal to 48 watt. So from this we can get the ampacity I equal to 48 minus divide 12 equal 4 amp. So this is the I, and then more than this, what we need? L. We need L. The question asks us the L. We need the F. F is 2 from this table. F, you can find out F from this table, and F is 2 for this question because it's DC current. And so voltage drop VD equal to 12 by 5% equal to 6.6 volt. And then what we need more, let me to bring the main VD equal this one, copy this one and paste. Where is the R? Paste it here. Okay, paste it here. So what we need? We need L, because the question asks us about the length. So this one, L equal to VD by 1000 divided by F K F I. Okay, now we need L. Now VD is 16 by 1000 divide K. Oh, we don't have K, but we have the size of the cable. So we can use this table D3. These numbers, all of these numbers are K, and these numbers are the size of the conductor. So the question tells us 10 AWG. So this row can help us, but because it's DC, so the K should be 4. So 4, let me to write it here. K equal to 4 from table D3. We got it. Okay, so we got it. K, what was K? 4 by F. What is F? 2 by what is I? We got the I from the lamps. However, it was here 4 amps. So let me to use calculator. 600 4 2 4 18.7 meter is the answer. Okay, so let me to highlight this one as the answer. This one is the answer. I tried to use different question, and each question has its own trick and its own way to calculate. Just be patient and be with me till the end of the video. An apartment, so then you can be sure that you can get everything about the voltage drop for the Red Seal exam. Okay, an apartment unit is installing a 240 volt electrical baseboard heater rated at 25 amps. So we have the voltage, we have the ampacity located 45 meter from the distributed panel. What size of the conductor required? Keep voltage drop within 3%. So let me to copy the this one. Copy this one. You can find out this formula. You can memorize this formula, but you can find it from the table 3 under the table D3. Table D3. You should memorize for sure. You need to memorize table D3 is for voltage drop, and you can find out this formula here. Let's go to the question, and let me to paste this. So what we have the voltage drop percentage, we have the voltage, we have the ampacity, we have the length. So we need the K. So from this formula we can get that K equal to VD by 1000. Oh, this one is 1000. 1000. Put it in the bracket and divide by F by I by L equal to what is the V? What is the VD? VD is VD 240 by 3%. 240 by 3% by 1000. F divide F2 is 2, I is, we have the I in the question, I is 25 and length is 45. 25 or 24? 25 by 45. So let me to see the 240 by 3% by 1000. Oh, let me 1000 divide 2 divide 25 divide 45. 3.2. Okay, now we need to check the table D3 to find out the cable size. But let's see what is the trick here. We don't have actually for it was about AC circuit 240 one phase circuit. So here you are, we need to check this column, but when we check this column we can find 3.2 3.2, but because let me check this equation. VD equal K equal to VD with some constants. So when we need to VD not to more than one constant number. For example, we don't want to VD be more than 3% of voltage, so the K should not be more. The K can be less but not be more. So our calculated K is 3.2. So we can't choose 4. We can choose this one, and the cable size should be 8. So because of this, table D3, and we assume new K equal 2.5 less than 3.2 is acceptable. So from this we can realize that cable size is number 8 AWG, and this one is the answer, the correct answer. So let's go to the next question. What is the maximum circuit length for So this question asks us, now you can answer this question because we solved 4 questions and you are ready to solve this question. So we had L here, L. Okay, copy this one, paste this one. Okay, equal what is the VD? We can get it 12 by 5% because question tell us 5% voltage drop, 12 volts, and by 1000 divide by K. So we have the number 10 cable. We'll go to the table for 10. We can see that this one is 4. So K is 4. K is 4. F, what is the F? We can find the F from here. F is for DC, F is here 2, and for what we need I. What is the I? 3. So let me to use calculator. 12 by 5% by 1000, divide 4 to 8, 8 divide 3, 25 meter is the answer. So this one can be the answer. Thank you to be with me till the end of this video. I try to record more videos depend on the subjects of the book, and also this can help you to understand better of every subject and solve more questions, so you can be sure that in the exam you can get good questions, 70% of the 100 questions, and pass the exam. Let's go to the next videos.